Okie doke. Welcome back, arcade and electronics enthusiasts. We're getting ready to start a new one today. It is a Gorf board set. I'll be right back. I'm going to go close this door really quick. And somebody Frankensteined me together the worst Gorf board set on the planet and sent it for repair, which is going to be fun. It's like every board has a message that it's no good. This board says bad graphics. And what I want to do is I'm going to test all of the tantalum capacitors, make sure they're not shorted. This one should not be shorted, and it's not, because it doesn't filter 12 volts. It's the 12 volt filters that pop. And this one just says bad, and this one's got nice ceramic RAM chips on it, which I like. So let's just check these all out. Okay. No shorts. I do want to just that is not shorted. They will be shorted to ground if they're shorted. And none of these are shorted. Okay. That doesn't mean I'm going to leave them in. This one just says bad color. Whatever. Oh, these ones are already cut out. These ones are already gone. So which one of these is the 5 volt filter? On a 4027, the 5 volt line is -5. I think it's pin 1. Yeah, pin 1. And this is ground, which is down right here. Pin 1 is 5 volts negative. So it's this top guy. So what I'm going to do is I'm going to go ahead and clip this negative This one looks fried. This one absolutely looks fried. This one is fried. One of these blew up. But it opened up, it didn't short. And that's good. I think it's the 12 volt. I think it's actually the 12 volt line. So let's find out which one of these is 12 volts. It's this one. The middle one is the 12 volt line. And that's the one I believe that blows up. And this is going to be the 5 volt line. Yes. And then you have the -5 volt line. So it goes 5, 12, -5. One of these blew up, and it's probably the 12 volt one, and it's, can't tell. I think it is the 12 volt guy. It's usually always the 12 volt guy that fries. And it was, yes. Explosion. Yeah. And it blew up. And it does not look like it damaged that one. Well, the good news is it burnt open. It didn't short. But you know what, I'm gonna replace all of those, so I'm just gonna clip them all out. tantalum's just... There we go. That was bad, and it could have been... Well, it didn't short, so who knows? Who knows? Okay. Our game board. And we have two customs here. Speech chip. Chip is missing. This guy's been removed. That's a dip switch, I think. Well, let's see if any of these are shorted. No. No. Yeah, it doesn't look like any of these are shorted out. That's like 2 volts though. And this is going to be ground. So this one, that's pretty high. Okay. No, none of them are shorted. That's good. All right. Let's go here. We have our CPU board that says missing heatsink, non-working. And our CPU board here. These two both benefit from a heatsink, actually. Now, are these any good? Who knows? I can test them. I have a complete board set. I have a working Wizard of War set that I bought. I bought it specifically for testing this kind of stuff. Okay, no short. No short. Good. And this guy, I think I already tested this one. This is the pattern board. It says bad graphics. That one is not exploded either. And then you have your ROM board. The ROM/RAM board. One of those little tantalum dudes on there. Okay. Not shorted. Okay. All right. Yeah, there's going to be a lot of work on this set. This set is going to take a lot of work to get right. Every board has an issue. So, okay. What is the first course of action? Geez, I don't even know where to start. CPU board. I want to make sure the CPU and the ROM/RAM board, first thing I need to do is the CPU board, make sure it's good to go. So I think I might as well get my Wizard of War set out, swap this CPU board into it and see if it works. And if it does, great. what I'll do is replace these 3 sockets and put heat sinks on these. And I think this is a 5-volt filter. So let's see what this is filtering. This is probably 5 volts. And it is, yes. This is a 5-volt filter, so it should be fine. This thing should never blow up. It's just them 12-volt filters that blow up. And there's probably one on this game board which will need to be replaced. So, clipped out. Any one that filters 12 volts, you need to get it out of there. The other voltages, they seem to never blow up, so it should be fine. Okay, so I'm gonna go. I got to get my harness out. I got to get my my card rack stuff out. Get it all hooked up. I think I'm gonna get my Wizard of War set and look into this CPU board and see what we get with that. So that'll be number 1. All right, I've got this complete set in my cage, my test cage. This cage needs some work. Number 1, it does not have the bars that go across, and it's dirty. So we'll work on that one. As for now, I've got them in my cage, and we did go through, made sure nothing was shorted, so we shouldn't be blowing anything up. And I'm going to run it on my black and white monitor. So, yeah, we should be good to go. Go ahead and set the camera. I'm going to set it up here so that I can look at some voltages right off the get-go. Okay. All right. And I will go ahead and fire it up, and hopefully nothing smokes. Everything is in the correct way. Okay. I don't see no smoke. .09 volts, 5 volt. Be turned down just a touch. Yeah, 505, maybe a little smidge more. And 501. Nice. Nothing on the screen at all. Nothing going on. Let's check out some other voltages, shall we? If we can find them. -5, 12.6. That's all of our voltages. Looking decent. Yeah, but this thing isn't doing diddly squat. There's nothing going on, so yeah. No life. Just blank screen. I'll just turn it off. There's no use in having that on. It's not doing anything. I just got this harness all put together, by the way. My Gorf harness is just done. Okay, well, what do we do first? Like I said, I do have a Wizard of War board set. I would like to test this board in my Wizard of War, this CPU board. You know, I'll have to do that just to, because it's got those customs on it, and there's no way to really test those. I mean, you can probe them, but it's easier just to do that. We got a ROM board here. I can test all of the RAM. I can test all of the ROMs, dump them, make sure they're good. 2532s. They're actually masked ROM. They're not exactly the same as 2532s. Oh, yeah, they are actually 9332. Those are maybe not exactly the same. Nope. Nope, they are not the same. Pin 21 is held low instead of high. So these are not exactly the same chip. That can be changed through these jumpers, but I don't know exactly. You'd have to look at the schematic to change the jumping. You can dump these. You can dump and read these by just lifting pin 21 and then putting it in your reader. Yeah, those are masked ROMs. That's the only difference is pin 21. On a 2532, it's held to 5 volts. On one of these masked ROMs, it's held to ground. So. Yep. Okay. So I think I'll get my Wizard of War set out. I got to change the harness and everything. And start doing some preliminary testing on some of these boards. The common boards, the pattern board, the RAM cards, and the CPU. I can test all of that stuff in my Wizard of War set. So I think that's what I'm going to do. Alright, I got my Wizard of War set out. And it just went a little bit strange. I mean, it's working. I don't know what this nonsense is. Let me mess with this and come right back. Alright, well, unfortunately, my Wizard of War set took a crap. The game board on my Wizard of War went bad. So this is my Wizard of War set along with the Gorf memory board and game board from the set that I'm working on. And those two boards work. Now we don't know about the sound custom, but so far so good. Yeah, but my Wizard of War started working like this and then it died. So, yeah, I don't know. We'll see. But this is good news. At least we got this going. But I think the first thing I'm going to do is I'm going to fix my Wizard of War board set. So, I need to look at my game PCB and find out why it died. But, yeah, this is good news for the set that I'm working on. The game board and the memory board seem to work fine, which is nice. Okay. Alrighty, yeah, let me do that. Yeah, I need to fix my whatchamacallit, my Wizard of War. So I'm gonna do that first. Find out what died on that thing. Okay, well, very bad news. I have deducted that both of his customs are bad. The board's good. The Z80 works. The board works with my customs in it, but these ones are both dead. So that's not good. Good board, bad customs. So I can get it fixed and test it and everything with my customs in it to get it working right and everything, but then you have to source customs, or if you have another board set or whatever. So yeah, interesting. Okay. Now I'm going to move on. I got to fix my Wizard of War. All right, more bad news. My Wizard of War, I think I lost this is my Wizard of War custom chips. And I think I lost one. I put one in the Gorf, and I think this one went bad, unfortunately. So I'm going to test this one and see if that one will boot. But that is the nonsense that I was seeing on Wizard of War, so I lost a custom chip. Darn it. Okay, I got my Wizard of War board set back together. This one did go bad, this one custom. Now I've got it on the sound side. I believe this is the input side. And you can have it over here, you just don't get sound. But it boots and runs anyway. But yeah, it's unfortunate. I lost one of those. And what's worse is I kind of blame myself because I didn't have caps replaced. I had them cut out. I had all the caps cut out, but I did not have them replaced. And you do need the capacitors in the board, because if anything, they'll allow a little delay while they charge, and they'll just apply a smooth, unspiked voltage to your parts. A lot of times you turn the power on, you'll get a power spike, a voltage spike. These capacitors are on those voltage lines for a reason, to dampen them spikes. And I didn't have the caps in the board. I had them clipped out, but I forgot to replace them, so I kind of blame myself. This thing took a spike, obviously, and it killed it. So don't just clip the caps out and leave them out. They need to be there. They're there for a reason. They're spike dampeners, you turn the power on, you get that little voltage spike, boom, 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 that'll take care of them spikes. And yeah, so unfortunately, that's what happened. Anyway, I went through and made sure that my whole Wizard of War board set was capped. And I will replace all of the caps on this set. But I need to order more caps, because this thing takes 3, 6, 7, 8, 9, 10, 11, 12, 13, 14 of those caps in total on one of these sets. Yeah, so let me count that again. 3, 6. This one only has 1. So 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 of those caps. 15. There's one right there that I forgot too. See that one? I forgot that. There's 15. So I'm going to stop. I'm going to replace that cap as well. 15 of those things. Okay, now in this cap that I just put in that I noticed I didn't have, if you follow the positive trace there, it comes over, goes down and hits these two bottom caps here, and those are right here, and those go up to those two chips. So they're filtering a line that goes to there. I don't know what that pin is. Yeah, but so yeah, this filters something to do with these. So it's got to be there. All right, welcome back, guys. I am checking out this pattern board that was bad. And remember, when I had this on the tester, this is what it told me. X wide bad, flip bad, 1-0 status, and area CT and adder bad, bad adder, the bad adder. Anyway, that, as I suspected, I got the schematic for this board printed off here, and it really doesn't, that test doesn't really help you much. The schematic is nice because it's got everything sectioned off, so it can kind of point you around, but then you just gotta, something, basically this is the problem. Something that is affecting the circuitry for this circuit could be in a completely different circuit, but it's reading as that's bad. So that's what is kind of bad info. It's misinformation. You know, get the government on it. But yeah, so what I've been doing is just kind of probing around and using my brain to say, does this look right? I'm just kind of looking at the schematic and going over stuff, poking around basically is all I'm doing. And I've come across a up-down counter that is right here, U9. That looks not quite right to me. Let's go ahead and probe this thing. You see the, let's look at the control first. We have a input carry on pin 5 and the up-down signal is on pin 10. So if we look at pin 5, which is our carry from, it's our carry from this counter. This is the lowest significant count in the chain, and it's activating this one to count. It's not activating this one to count, it's giving an extra bit for this one to count, if that makes sense. Anyway, pin 5. Pin 5, there is that bit from the other counter coming in. That's good. That's good. Pin 10 is the up-down, so it's 9. This is the up-down signal. We are counting up all the time. From what I can see, we're always counting up. Okay? Now if we look at this signal, which is reset, that goes to pin 9, and this is a active high reset. So when it goes high, it will reset the count. So pin 9, and there's that reset, and you can see it is not ever resetting. Right? It's never going high. What does that tell you right now? What should our count look like? What do we know about this counter, knowing what we just probed? That's a question for you. What should you see? We're always counting up and we're never resetting. And we have an enable here on a parallel load. And that is a parallel load high. So whenever that's high, we're loading what is on the inputs. So let's look at pin 3 really quick. I may have jumped the gun. Nope, I'm even more satisfied with my conclusion now. That is parallel load. Or that is pin 3, which is the most significant bit of the count. Pin 3 that I just probed, and you saw it's going high, it's going low. What was pin 2 doing? You remember? Or we didn't look yet. Let's look at our outputs. Outputs are 6, 11, 14, and 2. 6 being the least significant. So here's pin 6. Alright, looks like a count, doesn't it? That's what a count bit should look like. So we got 6, pin 11. Here's pin 11. That looks like a count bit. 14. And that looks like a count bit. And let's look at our most significant count, which is pin 2. And this is pin 2. Pin 2 is our most significant count, and it is always low. Should it always be low? Is the probability that this should always be low? Let's use some just common logic here. Let's think about this. This chip, we have pin 1 is parallel enable. Remember, the most significant bit coming into this thing is on pin 3, and it is high. Oops, that's not pin 3. Yes, pin 3. That is the most significant bit coming into that counter on pin 3. And this was and that was our count bit. So it's 3 out to 2. Okay. Pin 15 is the clock. There's your clock. Looking good. Back to what I was saying. Should this most significant bit be low all the time? Because that's what it is. Pin 2 is low all the time. Pin 2, low all the time. That pin's input is pin 3, which is a data bit. It's high, it's low, it's all over the place. It's high a lot, it's low a lot. We are never resetting the count. We are always counting up. We are always adding a bit to count. And our most significant count never is 1. That to me sounds to me like a bad chip. Because this thing's never resetting. It should always be counting and terminating. Yeah. So I think we have a bad bit right here. And that is in the area control. Remember, it said my area control was bad. And that goes to U8, half of U8. The other half is right here. And that's linear control. Yeah, who knows? I'm gonna consider that this chip is bad, because it doesn't look right to me. That's a 4516, which I don't have any of those, so be put on hold for a little bit because I don't have not one single 4516 chip. So yeah, it looks kind of like a 393 or maybe a doesn't really look like a 191. I should check and see if there's a TTL equivalent to this chip. Maybe I can get by with that, but yeah, so all right, I'll be back. All right, and after that whole rigmarole of explanation on theory about whether that chip is working or not, I decided off camera, well, I better, just make sure. And this is what I love having a logic pulsar for. I'm going to restart the board. Because you can take the guesswork out of this by introducing pulses to that parallel load pin. We know that we have high signals on the input. So maybe, just maybe, that parallel load is happening in a timing manner to keep that highest bit from going 1 and keeping it low. It is possible, but it's kind of not always probable. But it's good to keep it in your mind also that it may be designed that way, to be hitting a parallel load to keep that highest bit from not counting high. So you can actually force it by introducing pulses to the parallel load pin out of time, just by force, and then probing that highest bit and see if it toggles. That'll tell you that it's not stuck low. And that's exactly what I just did, and I'm going to demonstrate that. I'm actually going to point the camera at the scope, and I'll let you know when I'm introducing on pin 1 the pulses, and you'll see. So let's do this, and move down and zoom a little bit, move over a little bit, and okay. Now what I'm going to do is I'm going to put my scope probe on pin 2, and you'll see, remember, it was low all the time. Yeah, that's wrong chip. Okay. Low all the time. Now I'm going to take my logic pulsar and introduce pulses on that parallel load pin, pin 1. And here we go. See that? That's that highest bit. Now I'll remove the pulsar now. And it went back low and it stays low. So apparently that is not a bad chip. So I will keep looking. Alright, I got the test boards back out because I'm figuring, why not work on this with this like this? Why not? Anyway, and while I'm working on it, I don't have to have the ROM board. I don't have to have the game board in there. Yeah, why not? But now it's only given me bad area LD. It's given me, I mean, I was looking for a lot of stuff that apparently wasn't bad. I don't know. And I've done reset this thing. I'm hitting reset. I've turned it on and turned it off. And this is what it's telling me now. Bad area, is that load? Bad area load. So let me look into that and see what that might be. Oh, and just while I have the chance, this is a pattern board that I bought on eBay for $35. I seen it about a year ago. It's been about a year. I saw this on eBay and I was like, holy crap, I just bought it. 35 bucks. Let's see how it is. I've already put it in the cage and it worked and looks good. Looks good. Yeah, that's the one, $35 special. Yeah, back to this board. Bad area load. Bad area load. 3FFF. I wish this thing had better. It doesn't tell me anything about that. Come on. Come on now. Bad area. Area. Yeah, I don't see anything talking about bad area. Here it says area in linear high 2 bits. In area U9, U8, we're back to these two guys. Remember, those are the two counters that I was looking at. Yeah, who knows? Who knows? I think I just need to scrutinize this area right here, this section. And it starts here with some 175s. You're getting data bits from the CPU board. So we know that's good. And then the CPU, you know, that data bus comes down through here. And then you got data bits being picked off in these counters right here. That's these two guys, U9 and U8. Well, U9 and U18. So 9 and 18, these two guys. And also we have those two data bits, those very same data bits going into 175s being latched in 175s and then added with, it's like a re-loop here. You got 175s here, and it's adding to itself and summing out to some more counters. And then that is being picked off, and these are being muxed over somewhere. 35 and yeah, I don't know. U35 and U26. Who knows? This is giving me a headache. Is there another sheet to this that I'm missing? I'm going to have to check that out. But, yeah. Maybe there is another sheet. Boy, that would be a pain in the ass, wouldn't it, if I'm looking at half of the schematic? Yeah. Anyway, going back to what I was saying, I think I really need to just scrutinize this section of the schematic. I think there's something faulty in here. And I don't think it's something simple as far as looking at a floating line or something like that. I think that there is just an there's a signal that looks good that's not good, if that makes sense. You have to actually analyze it to find it. And it's tedious, and it's just going to be going through this section. It's easy when they're floating, you know, or if they're stuck, high or low, you can kind of deduct whether it's supposed to be stuck or not. And then you can use your logic pulsar to introduce some pulses in there to get the thing to pulse high, and if it does, then you know it's just designed that way. So anyway, I'm going to go ahead and kind of go through this and see if I can't track down this issue. Bad area. And I'm going to see if I'm missing part of the schematic. Do I need another page? So, okay. Well, I will be back. All right. Well, I have a mess of wires here, and I'm looking at area load is bad. Area load. Okay. There was another schematic. It's the same schematic, but it has different stuff is named different. Area counter, area control, area load. Area load is not named on here. Area load consists of, you can see it's kind of these 4 chips. This one, this one, this one, and that one. And then you have feedback. So area load says it's bad, so I'm looking at these four. These are 175s, and these are 4516 counters. I'm looking at the counters, and I've got it hooked into this, and this doesn't do anything until you hit reset. So I go ahead and hit single, and I'm going to kind of make it a little smaller, and then hit reset, and it will count a little bit. I'm going to do this. Okay, there we go. And I'm going to stop it. And if we look at this one, I've got it set. Here's clear. It clears on high. So we're not going to clear. Up, down is just like that. If it's up, if it's high, it counts up. If it's low, it counts down. This is parallel enable, which is active high. So if it goes high, it loads what's on the parallel input to the output. And then input and output and carry out. And these are active low. These carry bits are active low. So if this goes high, no, this one is always carrying in a bit. Right? Input. Yeah, I'm not exactly sure. I think if it's low, it's adding a bit to the input. Maybe. I really don't know, to be honest. I'd have to read the data sheet on how that works. But anyway, I'm going to make this bigger and then kind of move it over. Oops. And you can see right here we have 2 on the out. So at this clock pulse, it counts up to 3. And then we get a parallel enable pulse. And there's 2 on there, so it goes to 2. And that's really all this one does. So as far as I can tell, this guy's working fine. I'm going to go ahead and hit reset one more time on here. And I think you have to put it on repetitive. There we go. Stop. And then you can do the same thing. It's 2. You know, there's your count bit. So it counts up to 3 and then it loads 2 and goes back to 2. Alright. Now if I put that on there and let's shrink it just a little bit. Okay. If I put this on this guy and hit reset, and now we'll look at this one. Let's stop it and make it a little bit bigger and move. All right, here we have a clock pulse. We have a clock pulse. This should have counted up. Parallel enable. It's not cleared. It's counting up. There's no parallel enable. On this pulse, this should have counted. Now we have a parallel enable, so it stays 0. All right. Let's try it again. Let's do a single and reset. And it just seems to be stuck on 0. Oops. Okay, I saw 4. Let's catch it on 4. Input. Let's trigger that input at 4. Trigger. Okay. Let's clear this. And let's stop it. Let's clear the trigger. And we want to trigger on A. We're going to trigger on, what was it, the output being 4. And let's, come on. Single, reset. All right, here we go. And let's make it a little smaller and try it again because it's small. Okay, see if we can see what's going on. Parallel. All right. This is just kind of difficult. It's hard to do this like this. Alright, I'm going to have to try to catch the clock on a 0 pulse too, I think. Or just low or something. See if it'll... There we go. And there you go. This is what I'm talking about right here. Although I don't know if that should have counted there or not. See, this is this is a parallel. Should this have counted right here to 5 and then went to 0? I don't know. That's an awful. Oh, that's 2 microseconds. That's not even in the nanosecond range. Absolutely. This should have counted to 5 right here. You have a clock pulse. That should have counted to 5 and it's not counting. It did parallel load. It parallel loaded back to 0. But it should have counted to 5 right here, just like that other one was counting from 2 to 3. This one is not working. This guy right here is not working. U27 is bad. And I don't have any of these chips. So I'm going to go ahead and test every one of these 4516s. So far, this one is the only one that is not working right. This one seemed to be working fine. If you remember, it would count from 2 to 3 really quick and then parallel load back to 2. This is the same scenario where it should count right here to 5 and then parallel load back to 0. Yeah. So... Alright, well, I'll be back. I'm going to have to order some of those chips, and I'm going to just, there's a lot of those counters on this board, so I'm just going to go through and look at them all. Alright, everyone. Yeah, I went and I got the data sheet out for, I printed off the data sheet for this chip, that 4516 chip. And it's an up-down counter, and it has it's called a carry in and a carry out. And really, the carry out is just a low at the terminal count. You know, it's just like a 161. How at the terminal count of a 161 it goes high. Well, this it goes low. It's a ripple bit. And then the carry in is nothing more than a count enable. That was confusing me. Carry in, like it's I didn't understand what that was meaning. And after looking at this waveform and the truth table here, it's just a count enable is all it is. It has to be low for this thing to count. So knowing that and understanding more how it works, I went through, and there's a ton of those chips on this board. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I didn't see where any of them were bad. And this is a little example of how it works. I renamed this count enable. And when it's low on the rising edge of the clock, it'll count. And you see rising edge 11, 12, rising edge 13. And I can do a bunch of these samples too. See, this is the count enable's low the whole time, so every rising edge will count 6, 7, 8, 9, 10. So yeah, this is working fine. 9, 10, 11, 12, 13. 7, 8, 9, 10. Yeah, and right here, when the count enable goes high, it doesn't count on this rising edge. It stays 8 for longer, twice the duration. So yeah, I've found that those are working fine. So, and I've spent a lot of time testing those chips today. So we'll move on to, and these are the hard ones. The rest of the stuff is easy. I just wanted to get these counters out of the way. A lot of it after this is just kind of gating stuff. There's a couple counters here, adders, I'm sorry. There's a couple adders, 4-bit adders, that I would like to look at tomorrow. There's only 2 on the board. It's U29 and U38. So it's these 2 chips right here. 2 adders. I'd like to check, make sure they're working. I got a couple 175s here to look at tomorrow. Those are easy. I can do those with the little scope. I have to use the analyzer for these 2. But the simple gate stuff, the simple flip-flop type stuff, I just use the little scope for that stuff. But I am done for the night. We'll see you tomorrow. Alright, I have found the problem on this board, and contrary to what the test was telling me, remember it was telling me load. It was telling me the area load, which according to this, the area load is these 4 chips, right? 1, 2, 3, 4. I'm sorry. 1, 2, 3, 4. Area load, and then you've got this feedback. I tested every 175, all of those 516 counters, analyzed every one of them. And you can see all the green dots on the board. When I have the analyzer set up, I just do everything on the board. And there's a lot of 175s and a lot of those counters on this board. And I analyzed every one of those. And they're not bad. None of them were bad. I thought I saw some of the counters bad, but it turns out I was just analyzing it incorrectly. And once I figured out what I was doing wrong, I went back and looked at them, and there's nothing wrong with those counters. So yeah, there's a line of 257s right here that I did not analyze. I probed them and I didn't see anything dead or anything like that. That was the thing about this board set, is that there was nothing that looked dead on it. And that's what makes it so difficult to it makes it tedious to test these, is when there's just signals that just aren't right, but they look good. You really can't, unless you're guessing, unless you're just guessing and getting lucky, it's hard to test those without having an analyzer. It's nice to have an analyzer because you can actually see where the fault really is. And you can see this is all jacked up. But this is, there's 2 4008, they're those counters. Adders, I'm sorry, they're adders. They're 4-bit adders, full adders. And first, let's come up to this guy. There's 2 of them. You know, that chip and this chip are the 4008 adders, and they're they're not pin compatible. They're function compatible to a 7483. So what I did was I just loaded up my 7483 program into my analyzer, but the pin, you have to make sure that you pin it right. because the pinout is not the same between the two chips. Functionally they're the same, but it's not the same pinout. And if we just look at the adding here on this chip, we have 15 plus 0 is 15, right? 4 plus 0 is 4. 13 plus 0 is 13. 1, 10. See how these two numbers are adding? Right now this is adding a whole lot of everything, just a bunch of nothing. Let me make sure I don't have this thing triggering on anything. I'm just going to clear the trigger. Okay. And let's try to get something nice and creative. See, you can see right here though, the input being 0. 0 and 14 is 14. Here's 1, 4, and 1 plus 4 plus 5. Or 1 plus 4 plus 15 is 20. 0 and 4 is 4. What's this over here? We have 1 plus 4 is 5 plus 2 is 7, right? 1 and 4 is 5 and 11 is 16. See, this one's adding fine. Now, let's, 1 and 4 and 10 is 15. Now let's move down to this guy right here. This is the other counter in that chain. This is U38. It's right here. It's the first count in that chain. And you can see here, it's never going to be adding anything. There's never a carry in. There's only a carry out. And I have the carry out bit. I have a 5-bit output. So my carry out bit is integrated into, like if I have over 15, you'll see it in the final count, because I have it integrated in. I have 5-bit output. So let's move this down. Okay, now we're on that guy. And let's come over here and do some counting. We have 0 and 4 and 9. That should be 13, it's 15. You see that? Here we have 4 and 10 is 12. 4 and 11 does not equal 13. So yeah, we have, this counter doesn't work. 0, 1, 0 is not 3, it's 1. So is the 2-bit stuck high? Let's see. This should be 16, which would be 1 and all zeros, right? 16, 1, it's giving me 28. 1 and 15 is not 28. 13 and 10 is 23, not 21. See, it's not, I mean, a bit's not stuck high. This should be 23, which would be 21 binary. It's not. I don't. I'd have to write it out, and I'm not going to do that. But you can tell it's just the bits aren't right. 0, 1, 1 and 13. Hey, that one's actually correct. 1 and 13 is 14. 1 and 12 is not 15. 1 and 14 is not 13. So this is the issue, this guy right here. That's a 4008. And I don't know if I have 4008 chips. Yes, I do. Excellent. So let's replace that guy and put it on our tester and see if it comes up saying looking good. All right. Got the test pattern, the pattern test board back in. Got my new adder in the board, and we're ready to go. And we'll go ahead and fire it up, switch it on, and see if we come back looking good. Hey, look at that. Look at there, looks good. Okay, great. So let's set it back up. Put it in. We got our repaired RAM card, our repaired pattern board. I put a, where is that? I put a dip switch in the game board. It was missing. And I'll get my amp out. We'll see what the sound sounds like. Make sure all the sounds are good and all that. And put the speech chip in. Yeah, I do not leave that in there for testing. I take it out. It's right there. I got that emulated speech chip up there as well. So we'll make sure all that's good to go. Okay, we're all hooked up. I have my amp out speaker. That's hooked up. This is all hooked up. It's plugged in. And I've got the monitor out to that monitor now. So let's go ahead and fire it up. I do hear stuff out of the speaker, which is good. Awesome. I see Gorf coming up. Alright, I'm going to have to put the camera up on the tripod, and there's two different sound channels, so I don't know which is which. So yeah, let me do that, mess around a little bit. It looks good though. That pattern board's fixed. The RAM card obviously is good, so our board set is good now. Hey. Sounds good. That does. So that is the sound effect channel, obviously. So I should be able to switch over and hear some sounds, or some voice. I did put the speech chip in the board, so we'll see. I'm going to go ahead and set the camera up and take a look. Okay, let's swap channels. One of these channels is mixed with speech, I believe. I think that entered a coin. That's weird. Oh no, it's, yeah, my coin was grounded. Destroyed. Sounds good. Bad move, space cadet. It is raining like cats and dogs outside. Another enemy ship destroyed. Light dust, space cadet, Dorfians conquer another galaxy. Oh, I gotta plug in my controller so that I can actually play. Yeah. Now I can put these two, I should just combine the channels. But I like to do this so that I can see both channels and make sure there's no static on one of the channels or nothing like that. Let's see if we still have a coin. Nope. Push a player button. My Dorfian robots are unbeatable. You think so? Not
Got you, space cadet.
Too bad, space cadet. You cannot escape the Gorfian robots.
Too bad, space cadet.
That's good. That means both of the customs on the game board are good. So I'm going to leave it on this sound channel right now. This is some of the effects plus the speech, and I'm going to play another game on that, and then I'll play a game on the other channel. So you'll get to hear both channels in a game. I'm going to leave this one for this one though. So we put in a coin.
Long live Gorf. Survival is impossible, space cadet. Some galactic defender you are, space cadet. Robot warriors, seek and destroy the space cadet. Too bad, space cadet. I am the Gorfian Empire.
Alright, how cool. Alright, now I'm going to switch the sound channels and we'll play a game on the other channel. Okay, here we go. I didn't last very long. I'm not very good. I'm not too good. A lot of people give me a hard time about playing the game with the monitor sideways. I am not going to turn my monitor every other repair. There's no point in that. That's not. I'm not trying to go for high scores here. I'm testing to make sure it works. So I keep it oriented one way. That's it. Yeah. But okay. So well, this one is done other than the two customs on this board. Yeah, the two customs on the CPU board. The CPU board works. If it's got good customs in it, it works. But yeah, this is my CPU board out of my Wizard of War. Yeah, so. Yepper. Good to go, though, as far as everything else. So this one had, and you know what? This is the cage that came along with this, and this needs to be cleaned. I need to clean up this cage. It's pretty filthy. And then put the board set in this thing and make sure it works. I'm sure it will. It doesn't have these. This one does not have the cross members. I don't like that. But I did kind of inspect the pins inside of it, and the pins look fine. So I'll just clean it up really good, and it should be fine. I cleaned the gold pin edge connectors on all of this. This keeps wanting to short here. That's a coin button. But yeah, I cleaned all of the gold pinned edge connectors, and yeah, we repaired one of the RAM cards had a bad chip, a bad 74 LS08, and a bad RAM. The other one just had a bad cap, and the pattern board had the one bad chip on it. The ROM board I didn't have to do anything to. I didn't have to do anything but replace a missing dip switch on the game board. And their CPU board I just tested and verified it works, minus the 2 customs. And there's nothing I can do about that. All I can do is test it like this and send it back as working, minus the 2 customs. So, yeah. All right. Well, that's going to do it for this one. I'm going to just let this one sit here and run for a while, as usual. And, yeah. So we'll see you on the next Classic Arcade Repair. Gorf. Fixed. Along with my cards here. I am totally digging these. And this $35 special pattern board that I bought that tested working. Yeah, I don't know if I tested that on film on camera, but I did test it on camera, I think. And that thing works perfect. So these things are cool right here. I really dig having these. So, yeah. Excellent. All right, guys. We'll see you on the next Classic Arcade Repair. I just might play some Gorf today, to be honest. All right. We'll see you. And while I clean that cage, I'm not done just yet. I'll end the video after everything's in that cage. I went ahead and cleaned my address custom. Put some thermal glue on there. Cleaned it really good with alcohol, both surfaces, the aluminum sink and the chip itself. And I am gluing this heatsink on my my address custom. I'd like to have one of these on my data custom as well. And the cool thing is, with these low profile sinks like this, it will go in the furthest, it'll go in the outer slot. This outer slot, it'll go in that outer slot and go down even with these bars across it. So that's pretty awesome. You got to do what you can to keep those cool and hopefully make them last a while. I don't know if that'll help, but it'll definitely help keep them cooler. So it's a better heat sink than this thing. And put it on the outside of the cage, you know, the last slot. I'd like to put those on these too. Wouldn't, you know, I mean, can't have it all though. You can't have the heat sinks on this one and this one because there's just no room. But yeah, anyway. All right, I'm going to get in and I'm going to clean that cage up. So, and we'll be back. Probably won't do anything until tomorrow. I'm going to let this cure overnight, 24 hours. So, yep, I'll be back. All right, I'm getting this baby put together. I did not wait 24 hours, but this seems pretty good and solid. And a little heat won't hurt it. Won't hurt it from curing, I don't think. Here's my repaired pattern board. And this is the cage I cleaned it up. And yeah, this cage does not have the cross members. But I got it cleaned up really good. And caps, new caps on these. It's a nice, all ceramic rams. I really like that one. Okay, well, there's the cage. And we'll plug the cage in. Okay. And we'll plug the board in. I need my glasses. Okay. There we go. A nice Gorf harness that I made. Okay, make sure that our sound, you know what I would like to do is just I'm going to look for something to combine the two sound signals. Yeah, I can't, I'm not going to mess with doing that because I don't want these things separated. I want to be able to test the channels separate. So it is what it is, just leave it how it is. And these, there, we're here. That's all plugged in. The board set is plugged in. Okay, let's fire it up. And we should have Gorf here. And it's looking like I'm seeing Gorf. Yeah. Okay, something don't look right. Yeah, something ain't right. Something's going on. And it's got to be the cage, right? Let me try reseating stuff. Okay, we are back together. Well, there was still, I mean, it was, I washed this, scrubbed it really good, and then sprayed it really good with alcohol and left it for a good couple of hours thinking it would have just evaporated out and dried up. Put it upside down. This was completely, all of these channels were still completely filled with alcohol. So that's why it was goofy. I got the air compressor out, blow dried it really good. You can hear it. It's, you know. And yeah, so that was what was up with it. It works. It was just completely saturated with alcohol. Yeah. Yeah. But this is the actual board set minus, this is my board. You know, Wizard of War. That's my Wizard of War. All my Wizard of War boards have that sticker on them. But once again, like I said, this board works. It just, the customs are bad. So. All right, that's going to do it. And yeah, let me do this really quick. Switch channels. Okay, now I'm on the speech channel. Turn the volume up just a touch. And for good measure, let's play one more game. Sideways. Sorry everyone, but it is sideways. Very bad glare. That looks awesome.
Push a player button. Prepare yourself for annihilation. Space Cadet.
How freaking cool.
Crosshair Space Cadet.
Whoa, man, this is tough.
You will meet a Gorfian Doom Space Cadet. Too bad, Space Cadet. Try again. I devour coins.
You do devour coins, Gorf. How awesome. Super, super cool game. Okay. Alrighty. I'll just let this one sit here and run for a little while. Alright. And we will see you on the next Classic Arcade Repair. And bye for now.